Alright, welcome to the third video of the Kubernetes mini-series. In this video, we're going to go hands-on with some of the concepts that we've talked about before and begin actually creating pods and services. If you haven't watched the first video already, I recommend being familiar with at least pods, deployments, and services. With that, let's get started. For this tutorial, if you want to follow along on your computer, you'll need to have Node.js and Minikube installed. First, I'm going to write a quick Node.js app that allows us to test some code that we can deploy. So to do that, I'm just going to run npm init in my folder. I'll accept all the defaults. And then over here I have a package.json. I'm going to add a file called app.js, and I'm going to install Express and save it to the dependency file. Alright, for now, since this is a very simple application, I'm just going to go to the Express documentation and copy and paste the Hello World example. Now, for reasons we'll see later, I'm going to add a little bit of extra fluff here. I'm going to make a variable called number and set it equal to math.random. So what this is going to do is it's going to just generate a random number, and when we respond to the root URL, instead of just saying hello world, we're going to say hello, my number is, and we'll interpolate the actual number. So what this code does is it listens on port 3000, and every time someone accesses the root URL, it'll print out a string saying hello, my number is, and the random number we generated. Of course, this random number will not change between calls to the root URL. So that's great. Now, what we need to do is write a Docker file, because we need to bring this into a container. So the next thing we need to do is Dockerize this. To do that, we'll start by adding a Docker file. And for this, all we need to do is we need to start from node 10. So we'll use node 10 as our base image. And then I'm just going to set a working directory. So we can say workdir/user/data/node.js. It doesn't really matter what the working directory is. This just specifies a sort of home folder for our code. Then we're going to copy over the files that we need. Here I'm going to copy app.js into this current local directory. Again, this directory will correspond to the working directory set above. And then we also need to copy the files Node.js created for us. So package.json and packagelock.json. Then we need to run npm install, like so. We'll expose the port that this is running on. Again, this is listening on port 3000, so we'll expose port 3000. And then we need to simply give Docker the command to start this image, which is simply node app.js. So this will do is it'll first set a working directory, copy over all of the files that we need, and then install the dependencies. So in this case, we're using Express. So when we run npm I, Express will be installed. Then we tell Docker to expose port 3000, and we'll tell Docker how to start the image. This should be a review from the Docker video. If you haven't watched that already and need a refresher, you feel free to check out that video. The next thing I'm going to do is I'm going to start Minikube. I've already installed Minikube, so I'm just going to run Minikube start. I'll give it 4 GB of memory. It'll take a moment to start up. So in the meantime, let's go over how to create Kubernetes objects. So to start, I'm just going to create a folder called K8s. And inside that folder, I'm going to create a file called deployment.yaml. And this file will contain all the information Kubernetes needs to run our deployment. So note that Kubernetes objects are specified in a YAML file. This is the preferred way of using Kubernetes, although you can also do Kubernetes object manipulations through JSON. There are 4 key fields that Kubernetes looks for. First is the API version, which specifies which version of the Kubernetes API you're using. The next thing you need is a kind, metadata, and a spec. We'll go through each of these individually. The kind specifies the type of object that you're creating. In this case, we're creating a deployment. If you wanted to create an individual pod, you could replace deployment with pod, or if you were creating a service, you would write service for the kind. The next thing we need to do is give it some metadata. The metadata helps Kubernetes associate information such as a name with this object. So here I'm going to call this deployment a express deployment. This helps us to be able to understand what's going on when we look at Kubernetes objects in the terminal. Then I need to specify a spec. The spec is where the core of the object code resides. So the spec tells Kubernetes exactly what fields it needs to look at in order to create your object. For a deployment, recall that we need to specify a number of replicas. The number of replicas will tell Kubernetes how many instances of this pod we should create. In this case, I'm going to set it to 3. The next thing we need to do is specify a template. The template is the type of pod that we want to create. Remember again that deployments oversee a group of pods and can create new pods when pods die or need to be started. So the template specifies a pod template that we want the deployment to create. So since this is a pod object nested within the deployment object, I need to specify some fields pertaining to the pod. Notably, I need to specify metadata and I need to specify a spec. So you can see that metadata and spec are keys shared by multiple Kubernetes objects. For metadata, I don't really need to provide the pod with names. In fact, it wouldn't be useful to do so because this pod is going to be temporary and there are going to be multiple instances of this pod template. So I don't need to bother with that. But I am going to provide it with a label, a set of labels. The label I'll give it is app backend. Labels specify a way for us to group pods. In this case, I want to mark all of the pods that are created by this deployment as being backend. The spec field tells Kubernetes what containers we need to be running inside each pod created by this deployment. So we're going to specify a list of containers. In YAML, arrays are denoted by a hyphen. So when I do this dash, it means that the following object is within the containers array. The first container I'll give it, we'll give it a name. We'll call it express backend container. We'll give it an image. We'll call the image express backend. We haven't yet created any images, but we'll do so shortly. Next thing I'll give it is an image pull policy. In this case, I'm setting the image pull policy to never because I don't want Kubernetes to try to look up the image online. Since all the images will be built locally, we don't want Kubernetes trying to search online for the image. This will prevent us from getting image pull errors later on when we actually deploy the image. Next, I'm going to specify which ports this application needs. Ports is also an array, so I'll start it with the hyphen notation. And in this case, I'll tell Kubernetes that the container is expecting to be run on port 3000, since our application, again, uses port 3000. There's one more thing that we need to add to our deployment, which is a selector. The selector tells Kubernetes how it can find pods associated with the deployment. In this case, I'll do a selector, a match label selector, and then I'll look for the label app backend. Note that the labels you specify in the selector must match the labels specified in the template. Otherwise, you'll get errors when trying to create this Kubernetes object. That's it for this Kubernetes object. We'll deploy the actual deployment shortly, but before I do that, I want to create the service. So I'm going to create a new file here. We'll call it service.yaml. And then I'm going to, again, start with the 4 key attributes that are necessary for all Kubernetes objects. We need an API version, a kind, metadata, and a spec. The API version we'll just leave as v1. The kind is a service this time. For the metadata, we'll give it a name, call it backend service. In the spec, there are a few attributes we need to specify. The first attribute is type. I want this to be a node port service so I can access it from outside of the cluster. If you don't specify a type, Kubernetes will default to a cluster IP service. Again, as a refresher, a cluster IP is accessible only within the cluster, whereas a node port internally is using a cluster IP address, but is accessible outside the service because it creates an external port on nodes that the service is running on. For our selector, we need to tell the service which pods it can route requests to. In this case, since we created pods with the label app backend, we're going to tell Kubernetes that any pod with the label app backend can be connected to by this service. Then we need to specify how people should connect to our service, which we'll do by specifying the ports. So the first port, ports is an array. In this case, we only need to have one port, and we'll give it a name of HTTP, because this will be an HTTP handling port. We'll specify the port as, let's say, 8080, and a target port of 4000. Now, normally people would make sure that the port and target port are the same, because this can prevent confusion. In this case, I've intentionally made them different so we can see what each port value does. The regular port is the port that we want to be kind of outside of the pod, whereas the target port is the port on the pod. So when I specify a target port on the pod, that means that all requests to this service will be routed to port 4000 on each of the pods. The port of 8080 will be the port associated with the service. So when Kubernetes assigns this service a virtual IP address, we'll need to connect to the virtual IP address at the port 8080 in order to access the service. And then Kubernetes will forward those requests from port 8080 to port 4000 on the pods. Again, this port must match the port that we specified in the container port. So good thing that we're checking, but the container port here we specified as 3000, and here we wrote 4000, so that's a typo, my fault. But we need to make sure that the target port matches the container port on our deployment, which should also match the port that you're exposing in your Docker file, and of course should match the port specified in your application. So that's it for this service. Now let's actually get into running our Kubernetes application and creating these two objects. So to do that, I'm going to go to my terminal, and I'm going to type minikube docker env for Docker environment. So if you recall from the video on Docker, Docker creates an image registry whenever you start running the Docker server. In this case, I have a Docker registry running on my local machine, but Minikube also has a Docker registry associated with the Minikube virtual machine. If I don't run the commands specified in Minikube Docker environment, then my Minikube virtual machine will not be able to find the images in my local Docker registry. So by running these commands, I'm essentially telling the Docker CLI from my command line to talk to the Minikube Docker registry rather than the local registry on my computer. So we can do this simply by copy and pasting these commands. That will do all that we need. For a faster way, we can instead just run eval $minikube Docker environment, which is just going to run all of these commands without having to copy and paste. So that's a quick trick that you can use to set up your Docker environment. Make sure that your Docker environment is set up, otherwise you will not be able to pull images when you push them onto Kubernetes. So now we have everything that we need to start building our image. So recall that we haven't built our image just yet, so let's do that now. I'm going to list my local directory. I see I have a Docker file, and I'm just going to run docker build -t to give it a tag. And in our deployment, we specified a name of express backend for our image. So I'm just going to call this image express backend, and the path to the Docker file is just this directory. So we'll run that. This command usually takes a while, especially the first time when you pull from the Node.js image, it'll have to download the image from scratch. Later on, when you rebuild images, or if you build new images using Node.js 10, Docker will use the cached value and you won't have to wait so long. For now, I'll put a cut in the video and we'll resume when this command finishes. Alright, so our image was successfully built. Now I'm going to deploy it onto Kubernetes. We can do this simply using the kubectl apply command. We'll specify the -f flag indicating that the object we want to apply is stored in a file. Let's first deploy the deployment, which is specified in the K8s folder /deployment.yaml. So Kubernetes gave me an error saying that there was an error validating the file, that the API version was not set. So let's go back, and you can see that I forgot to type the API version. Here I'll just type extensions /v1 beta 1. The API versions don't matter, but you can look online for the differences between all of them. Now let's try that again, and you can see that a deployment has been created. If I run kubectl get deployments, you'll see that we have an express deployment created. This matches the name that we specified in the metadata. And it has 3 containers, 3 replicas already. If you had something that took longer time to get started, you might see 0 out of 3 or 1 out of 3 initially. The next thing we'll do is apply our service. So again, we'll use the kubectl apply command. We'll specify a file, and this will be in service.yaml. When I do that, you can see that a service called backend service has been created. If you want to see the status of the service, we can run kubectl get svc, which is the shorthand for service. And you can see that a backend service of type node port has been created. Internally, node ports also have cluster IP addresses, so this is the cluster local IP address. If I type this into my browser, of course, I won't be able to access the service. Now, if you were trying to run a load balanced external IP service, you'd be able to see the external IP address here. The port field is what's important for us. We can see here that kubectl gave us 2 ports, 8080:30981, and that we're running on TCP. The 8080 is this port that we specified in defining our service as the port from which people should connect to our service. However, if we try to connect to port 8080 directly, we won't be able to because this is specific to the cluster. Instead, we need to go to the node port, which was created by our node port service, which is at port 3981. So we need to connect to the node's IP address followed by port 3981. To get the node IP address of Minikube, we can simply run minikube IP. This gives us the IP address of Minikube, which I'll type into my browser. The port, again, is 3981. And when we run this, we see the text from our program, hello, my number is 0.786, so on. Now I'm going to wait a few seconds and then refresh this page, and we'll see if the number changes. So I refresh the page, and you can see that the number has changed. This is because we have several pods, each running the same service, and each pod generated its own random number. So you can see that when I connect to this node port service, the exact pod which is chosen by the service can change. If I refresh later, I may get a different IP address. This time, when I refresh, I get the number 0.314. So again, it's important to remember that the pods created by Kubernetes are interchangeable when we connect to the service. The service won't give us guarantees about which pod we're going to connect to. So now you have a good understanding of how to create pods, deployments, and services. Again, remember that we rarely create pods individually. Instead, we'll usually create them as part of a deployment. That's it for this video. In the next video, we'll look more at networking and how to accept traffic into our cluster. Thanks for watching, and see you next time.